Hello dear students, welcome back to the class. In the last class we discussed about this thing, the velocity time graph. Before that we discussed about distance time graph, isn't it? So now today we are going to discuss about equations of motion. So what is this equations of motion? Let me give an introduction. So suppose a body is moving in a straight line with uniform acceleration. A body is moving with a uniform acceleration and it's in a straight line. Then we can establish a relationship between the acceleration, velocity, time and the distance traveled by the body by using a set of equations. These set of equations are called equations of motion. What is that? If a body is moving in a straight line with uniform acceleration, then we can establish a relationship between velocity, distance traveled, then acceleration of the body in a particular time by using a set of equations. These equations are called equations of motion. These are very important topic in physics. The physics, V is equal to U plus AT. This is the first equation. Second one, S is equal to UT plus half AT square. Third one is equal to V square minus U square equal to 2AS. These set of equations, by using these set of equations, we can solve many problems based on the motion of a object. See, V is the final velocity, U is the initial velocity, A denotes acceleration, T denotes time. Here, S denotes displacement or distance, U denotes initial velocity, time, half, A denotes acceleration, time square. V square minus U square, that is the final velocity square minus initial velocity square equal to 2 into acceleration into distance or displacement. So these set of equations help us to solve many problems in the section motion. See, and now the next thing we have to do is we have to prove this. I just stated these equations and told these are the equations of motion. But we want to know, is it truth or not? So we have to prove each equations using a velocity time graph. We know what is the slope of velocity time graph. We have two inferences from velocity time graph. Slope of velocity time graph is acceleration, right? So using that, let us prove V equal to U plus AT. It's very easy. Just listen to me. Now let me rub this. So we are proving the first set of equations. For that, let us consider a body. Let us consider a body. And this body is moving with initial velocity U. So it is not starting from 0. It's moving with the initial velocity U and a final velocity V. So as it is moving with the uniform acceleration, we can represent it by using a straight line inclined to the x-axis. See, the body is moving with initial velocity U is the velocity. Here velocity, here it is time. So velocity time graph. So nothing is given for us. So let us name the origin as O. Origin O. The body starts its movement from here, so it is noted as initial velocity, and body stops the movement when it achieves a final velocity. To represent final velocity, we can use the letter, small letter V. So here, initial velocity and final velocity. And now here we have time. So to represent this time, let us draw it here. We can give T. Small letter. Let small letter T be the time. From 0 to T. That is the time taken. So this is all about the graph. We can name the points one by one. Let it be A, B. Let this point be C. Initial point be O, and we can extend this line to here, name it as D. This point we can name it as E. Once more, here we name it as A, B, C, D, E. These are the namings. Now we know the slope of velocity time graph is equal to acceleration, isn't it? Slope of velocity time graph is equal to acceleration. So before going to this section, you have to give an introduction. Suppose a body is moving with uniform acceleration. It starts its movement with a initial velocity u and its final velocity is v. We don't know what quantity it is. Just give u and v, as we don't know the quantity. Let it be 10 meter per second, 20 meter per second. We don't know what about that. We just give u and v. So it moves with the initial velocity u and final velocity v. The time taken for the travel is t, that much. Then after that, draw the graph and write slope of velocity time graph is equal to acceleration. In words you have to write. And now see, let's take the slope of velocity time graph. So we have to take the slope. Here, this is the line. How to take the slope? Just create a triangle, isn't it? Just create a triangle, and BD by AD will give us the slope, isn't it? That's how we take slope. If it was a triangle like this and we name it as A, B, C, the slope is AB by BC, isn't it? Such like here the slope is, as it was AB here, we take BD. So slope is equal to BD, and here it is AB by BC, so here it is BD by AD. Hope it is clear. Very easy. BD by AD. Now, what is BD? Let's take it here. In order to get BD, let's take it here. What is BD? So, this is BD. That is, total it is V, this much it is U. So, we have to get BD is actually total minus this much. This is the total, and if we reduce this part, we will get this BD only. So that is V minus U. BD is equal to V minus U. Now let's check what is AD. So this is AD. Bring it to the x-axis. What is T minus 0? What is T minus 0? That is T. Or we get A is equal to V minus U by T. Maybe you are familiar with this equation. This is the equation for acceleration, isn't it? A is equal to final velocity minus initial velocity by time taken. Wasn't it easy? Just draw the graph. Then slope is BD by AD. BD is equal to V minus U, which gives us this much place, that is BD. So V minus U divided by AD is time, that is T divided by T. Now take this T to the other side. So it will become A into T. A into T is equal to V minus U. We are taking this denominator T to the other side. So by T will become into T if we take it to the other side. AT is equal to V minus U. Now let's take this U minus U to the other side. So how it will become? That is, I am writing it here. Okay. Now we get AT is equal to V minus U. The steps, the same step. A into T, I wrote it as AT. AT equal to V minus U. Now let me take this U minus U to the other side. So minus U will become plus U. AT plus U is equal to V. See, our equation was V equal to U plus AT. We reached right there. So we can write it as, instead of putting V here, we can write it as U plus AT. So hence, this is the first equation of motion. We proved the first equation of motion. V is equal to U plus AT. See, this will be the first time you are proving something in physics. So if you have any doubt, see the video once more and make it clear. I tried to make it simplify as my level best. So you can recheck the video if you have any doubt. It will be very clear for you. It's very easy. So we get the fact V is equal to U plus AT. This is the first equation of motion. In the coming classes, we will solve second and third equations of motion by similar methods itself. If it is clear for you, those will be more easier for you. Thank you for watching. Have a nice day.